Hey everyone, welcome to Diversity of Life episode 10 with me, Nasi. As we enter the holiday season, I'm sure a lot of you are decorating your houses. Wreaths, fake snowflakes, lights, candles, little scenes and displays. But have you ever thought about what you're putting up? Why you're putting it up? For this month's episodes, I want to touch on some holiday themes, discussing some common plants and animals seen widely over this time of year. And for this week's episode, I'm going to be talking about mistletoe. This often green-leafed and white-berried plant is commonly associated with kissing. As the tradition goes, if you stand under the mistletoe with another, you're to kiss them. But why? Not that I have anything against kissing, but how did this come about? Well, let's first look at the natural history of the group. Mistletoes are actually a huge group of organisms spanning several families in the order Santalates. There are approximately 3,000 different species of mistletoes, and this is likely an underestimation of the diversity. Their diversification was likely to have taken off during the Pleistocene glaciation approximately 18,000 years ago. This is when they started to migrate northward. I briefly mentioned this group during episode 6 when I was talking about parasitoids. Mistletoes are known as hemiparasitic organisms. This means that they rely on the host for some nutrients, but mistletoes can actually photosynthesize and make some of its own food. How does it accomplish this? Well, here's the life cycle of the mistletoe plant. First, a bird or some other vertebrate eats the berries and the seeds of the plant. The seeds are covered in a special glue called weisskin. This glue can't be digested, and so as the bird poops out the seeds and the glue when it's nesting in a tree, the seeds stick to the bark of a tree. Once that seed is stuck, the seed germinates, forming a structure called a penetration peg, which drills into the tree and starts to take root. These roots spread out into the tree's xylem and phloem, or the nutrient reserves. The plant then grows leaves and berries at the surface, some birds eat the berries, and the cycle continues. This whole cycle can take about 2 to 6 years to complete, and as long as the tree is living, so is the plant. This actually is where the connection to the parasitoid episode comes in. Some mistletoe species rely heavily on the host, and so heavily that it can result in host death. This extra stressor of the mistletoe parasitism on the tree can be particularly bad in times of drought or stressful times on the tree. In a review paper by Gabrielle, Watson, and Pendle that came out this year, they discussed the positive and negative impacts of the mistletoes on a forest. Amazingly, tree mortality can increase up to 30% in stressful conditions with the mistletoe present compared to mistletoe absent forests under the same conditions. And because of a lot of this research on how devastating the mistletoes can be during the early 2000s, there was a lot of extermination work. They tried to eliminate mistletoes from a lot of forest systems to try and help the forest grow. But, as it turns out, this is actually the wrong course of action. In 2012, Watson and Herring published an account of a really amazing experiment they did with a mistletoe. They had a large forest and divided it into plots. In random different stands of this forest, they would selectively remove the mistletoe from the trees. Then, they recorded the activity of vertebrates inside the tree stands. The results showed that in stands with mistletoe absent, 34% of the vertebrates inhabiting these stands left. This means that 34% of the vertebrates relied heavily enough on this parasite that they needed to move after it was removed. Part of this is because there are about 90 species of birds that are called mistletoe specialists, that they only really feed on the berries of the mistletoe. But even accounting for these, this was such a huge number. There are just so many vertebrates in these stands that rely on the mistletoe for food. Reading this paper, it was just amazing to me that so many vertebrates relied on it so heavily. It really speaks to the complexity of food webs in our ecosystems. But with all this said, where did all the holiday connections to the species come from? Well, mistletoe actually has a long history with humanity. Some of the earliest religious connections of mistletoe to humanity date back as far as 370 BC. The Greeks, Europeans, Celts, Nords, they all had the same general idea. The mistletoe was a rare sight, and because it was so rare and so beautiful, that it must have been magic that the plant was there, and that cutting the plant and using it in various things allowed you to capture some of that magic. It may seem silly to us, but a couple thousand years ago, one of the supposed medical properties of the plant was that it could help people with epilepsy. The rationale was that since the plant grew on the side or underneath the branch of a tree and it didn't fall off, that meant that if you kept it in your pockets as an epileptic person, you wouldn't fall either. Another one of its supposed properties was that it could ward off demons. If you hung it up in front of your house, it would scare them off. When Christianity became more widespread, this is probably one of the adaptations as to why we hang it up during times of celebration, because it could ward off malicious thoughts or bad spirits. Mistletoe also has a rich connection to fertility with humanity. It was believed that if you chewed some or hung it up right near your bed just before the act, you would be more likely to bear children afterwards. This idea was probably also incorporated when Christianity became more popularized, resulting in the idea of kissing underneath the mistletoe, signifying good health and fertility. Mistletoe has a history rich in spirituality and health, while biologically actually having a detrimental effect on its host, no magical properties whatsoever. And so later on in its history of humanity, it actually became a nuisance and was starting to be eliminated. But in the end, despite this duality with humanity, it holds an incredibly important role in our ecosystems, many vertebrates relying on it for food. I hope you enjoyed this week's episode and learned a thing or two about this common holiday plant. As always, I want to hear from you guys. Did you know that mistletoe had such a rich history and interesting natural history? Have you ever actually seen mistletoe in the wild before? For the next episode, I want to know what you'd like to hear about. I was thinking about doing an episode on either reindeer, holly, or poinsettia. Which would you guys like to hear about? Do you guys have any other holiday biology related topics that you want to hear about during this month? Let me know in the comments below. Thanks so much for watching. As always, if you liked what you heard here, please hit the like button. If you want to see more, subscribe. And if you want to see more of my furry antics, follow me on Twitter. I hope you all have a very happy holiday, and I'll see you later.